Hello, my name's Shelby, and this is my oral exam. So first I'm going to do number 1, which asks to explain the concept of concavity. So I have my little note card here ready to go. So first up, it asks what it means to concave up. So this actually took me a really long time to figure out because I drew out little graphs here. This is concave up even though it's going down on the graph, and this is concave down even though it's going up. So basically, you can tell if it's concaving up if f of x is greater than 0 and the rate of change is increasing. So basically the y value is going to be increasing from going left to right instead of decreasing. So whereas when you're concaving down, the y value is decreasing going left to right. So, and the rate of change is also decreasing, which makes f of x less than 0, rather than when you concave up, f of x is greater than 0. So that's concaving up and down. And then down here we have the inflection point. And that's basically the point on the graph where it switches from concaving down to up or up to down. And it's when the y value shifts. So there's always, in every graph, there's a really specific point that happens. And sometimes it's abbreviated to POI, point of inflection. That confused me for a little bit. But okay, next we're going to do number 8, which asks why we can't measure angles based on arc length, which is the distance between two rays. So the best way I knew how to explain this is saying that the arc length never equals the angle. So if your arc length is like 15, your angle isn't going to be 15 because arc length is always measured in inches, and you don't, or inches, centimeters, feet, any kind of distance measurement, and you don't measure angles like that. So this I thought was a really good graph. It's two different sized circles that have the same exact angle. So I drew 90-degree angles here, and the circles are obviously different sizes. So since the circles are different sizes, this arc length here are different too. So this one's obviously way smaller than the bigger circle. So if your distance is changing, then and your angle's not, then your length obviously doesn't equal your angle. So I also put down here the formula to find your angle in degrees or radians from your arc length. So if you want to find the angle from the arc length, you take the arc length and you divide it by the radius, and it gives you the angle in radians, which makes sense because radians is the amount of radius lengths. So when you have this arc length here and you divide it by that, you're going to get that angle in radians. Okay, lastly, we're doing number 9. 8 and 9 were fresh on my mind, so I'm feeling pretty good. First I asked to explain what a radian is as opposed to a degree, and this actually took me a really long time to figure out how to explain, but the best way I could think to explain it is it's like two different languages. So like in Spanish you can say hola, and in English you can say hello, and they both mean the same thing, but they're very different words. So when it comes to radians and degrees, you can say pi or you can say 180 degrees, but it's both the same thing, if that makes sense. So radians are, like I said, measured in radius lengths, and degrees is probably what most people are more familiar with because you know, like 90-degree angles, and a straight line is 180 degrees and a circle's 360 degrees because that's what we always learned. So it takes a while to get used to being able to go back and forth, like you're learning a second language, being able to go back and forth between radians and degrees. But they both measure angles, both radians and degrees. And then to convert from radians to degrees and vice versa, you basically are going to take your radians or your degrees and divide it by either 360 or 2 pi, because a full circle is 360 degrees and 2 pi radians. So you divide it by either 2 pi or 360, depending on if it's radians or degrees, and then you multiply it by the opposite. So I have it written down here, it'll make it easier. So right here, I have d equals degrees and r equals radians. So I know this is backwards in the camera, I apologize. So you have degrees equals radians over 2 pi, because 2 pi is one full circle, times 360, because 360 is degrees. So that's how you transfer it over. So these two radians cancel out and you're left with degrees. And then you have radians equal degrees over 360, because 360 is equal to a full circle, and then times 2 pi, so that you're left with radians. It's really, once you get the hang of it, it's pretty easy. Okay, bye.